everybody for attending. And in my session, we'll cover API security from starting from the high level and going to practical practical advice on how to set up your API security program, how to quantify the risk, and what first steps you need to take in order to start solving the problems. So maybe a little bit of background on myself. I'm the co-founder and CEO of Neosec. Neosec is a leading API security company. Before that, I started another cybersecurity company called Cyber, which invented the concept of XDR, which is widely used today. And in my previous journey was acquired by Palo Alto Networks, and I spent there 3 years leading the product line. In addition to that, I also co-chair the fraud prevention task force at the FTX, Financial Data Exchange. There I'm involved with APIs that are implemented between financial institutions and aggregators and fintechs. So with that, I mean, I naturally have a lot of discussions with many CISOs and many different companies in different industries about their API security initiatives and programs, and I wanted to share some of the learnings today in this session. Let's move forward a bit. Okay, so in today's session, we'll cover a few topics. We'll start from digital transformation and how it's related to APIs. We will list some of the challenges in securing APIs and especially B2B APIs. And then we'll shift to some more practical tools of how to identify the risks, how to come up with the plan to secure APIs, and some pointers on where to start or how to start. So how are APIs related to digital transformation? So naturally, everything that is built today is part of some kind of digital transformation, and APIs are kind of the connecting tissue or the connectivity network today. I mean, I like to say that APIs are kind of the new network, because networking is something that is already kind of figured out. We don't really need to set up switches anymore and routers. We typically implement new stuff on cloud environments, and a lot of that is taken care of. Naturally, there's some basic network security and configuring the network configuration, the cloud configuration. That's important as well. But then the interesting things happen on the application layer, and trying to move it forward a little bit. It's a challenge with the way that it's. Oh yeah. So APIs basically are the connective tissue between different applications, different microservices, both internally and externally. And I think what's new in the last few years is all those B2B APIs that enable companies to create experiences beyond just one web application. Like, for example, if you're a financial institution, you want to enable fintech partners to access your data and provide additional services. Or if you're a payment company, you have to enable merchants to transact on your platform. All of those are B2B APIs. They don't necessarily have a web interface, but they're exposed to the outside, to authenticated parties, so that they can create these these different interactions. And by the way, just the last session that we heard from Yoni, that API for creating tickets, sounds like another type of API that is used, in a B2B fashion, or between product implementation on a backend. So all these APIs enable more and more functionalities, and they have to be exposed to the outside by design. So that is creating a lot of the need and the growth of APIs that we see. Now, why are attackers focusing on APIs so much? What happened in the last 2 years that caused attackers to focus on APIs instead of focusing on the infrastructure like they focused before? So again, to give you my perspective, my previous company, Cyber, was all about protecting the data center, protecting the internal network, the enterprise network. And at the time, about 10 years ago, that was really the soft belly, because the sensitive information used to reside within the data center, within the, these business applications were gated. Now, today, when we need to expose new functionality, we expose it through APIs. And therefore, all that sensitive information is exposed to the outside by design. So attackers today, if they want to actually gain information or steal information, PII, or create transactions, or do any type of damage of that kind, they really focus on these application environments. And like what Yoni showed, it's much easier to use that API interface to access that sensitive business system, rather than to try to hack into one of the employees of that QNAP company and see if that employee has access to any of their development environment. And if they don't, maybe they have a corporate network. But in the end of the day, it's really hard to actually get from the corporate network to the application environment, which is typically hosted in the cloud. So attackers just look for the easiest way to get to the sensitive data. And when the easiest way is by design exposed to the outside through APIs, this is where they're looking at. No wonder why we see most of the attacks happening on API and application environments these days. Now, what do we need to do in order to address that? Let me move forward a little bit. So typically, from a security perspective, we have one big challenge, and it's that the fact that we're always one step behind. On the business side and on the product teams, there are some developers that create the new functionality. There was a lot of discussion today about what we need to embed as part of the development process, but we also need to accept the fact that with CI/CD and continuous deployment of new capabilities, and the number of new capabilities that are deployed, the security team cannot be a gate anymore. We can provide the guidance, we can provide the tools, but it's never a situation where we're completely a gate to some process, especially in continuous delivery of functionality. Now, in most companies that we see, the APIs are open and used before the security team has a good understanding of what these APIs are. Or sometimes they have basic understanding, but it still it still requires much more work. So how can we address these challenges? Let's maybe first list these challenges in a more specific way from a security perspective. So let's first take a look on the infrastructure that we implement, and the different components that are part of the infrastructure. If these boxes in the middle are the microservices that are exposed to the outside, they can be authentication endpoints, payment, or PII, or any type of other APIs that we expose. We typically start by implementing cloud security. I mean, again, assuming that these workloads are implemented in the cloud. So cloud security enables to secure the infrastructure, to make sure that we don't have some misconfigurations and so on. But of course, that's not enough. That doesn't really touch the application layer itself. Now, for the application, we typically use something like a CDN or a WAF. That helps to prevent some DDoS or some known attacks that we can identify by signature, and that mostly relates to unauthenticated traffic. Now, we also use an API gateway to implement authentication authorization for APIs. But then all that green traffic that goes through the API gateway is that authorized traffic. And today, in most implementations, there is really no way to see what's going on on these green lines. What is that authorized traffic? Is it good? Is it bad? What happens if one of our end customers or partners gets compromised, right? I mean, if it's and by the way, Yoni's case was actually a very good one. It's not even a compromise. We just by accident left our keys in a place that others can see it. So what happens if somebody has the keys to our kingdom? Are we still going to serve the service the same way? So I guess the answer is that we need to see how our APIs are used, because these authenticated users and clients are really the riskiest traffic that that we have, and it's not enough to just implement authentication authorization. We also need to monitor our environment. So, being a little bit more specific about the challenges, we can actually kind of compare it to challenges of web applications. So web applications are a little bit more kind of known to many organizations, and people have some ways of dealing with them. I think what's interesting about B2B APIs is that unlike web applications, they typically have, we typically find many more APIs. It can be hundreds or thousands of API endpoints, and they can be used in many different ways. While a web application is typically one big application, that has a bunch of APIs, these other APIs can represent many different channels and types of clients. Now, the second difference is that the web application kind of runs our code on the client side, and so we expect a certain behavior of the client. On the B2B APIs, there's no way to run our code on the client side. So the client is implemented however they want to be implemented. It can be different programming languages, different environments, different processes. So we really don't have control over how the APIs are being used. Now, from an authorization perspective, these APIs that are, these B2B APIs, typically they represent many different entities or users that can access them. It's not necessarily just a regular end user. It can be a partner. It can be a service-to-service integration and so on. And B2B APIs are meant to be used in the background. They're unlike web applications that assume some kind of interactive user, the B2B APIs are meant to be used in the background. So we can't use something like an MFA for that purpose. Typically we create a token, we create some kind of API key and secret and so on, and we have to to kind of establish that trust and trust our client when they get connected. If it's a programmatic client, there is no meaning for an MFA or something like that. And then last but not least, when we build software today, we typically build it based on microservices rather than monolithic application. And what it means is that every microservice, when the microservice receives an authorized token, they have to serve that token. They can't really think about it and maybe deny service because that maybe they think that the user is compromised and so on. These microservices are very specifically implemented. They see a token, they have to return the right response. So there has to be a way to understand the user behavior, the client behavior beyond the specific API call, and that way is not actually within the code of that specific API. Now let's speak about abuse case analysis. So if we think about abuse cases, I wanted to start maybe with the statement that abuse cases are not vulnerabilities. We spoke about vulnerabilities. There are many different types of vulnerabilities. You only showed us a few of them, and of course vulnerabilities make it easier for attackers to get into our systems and to extract sensitive data that we didn't want others to have access to. But abuse cases are actually more generic. So when our APIs are abused, it can be as a result of a vulnerability, but even perfect APIs that don't have vulnerabilities can be abused. For example, when account takeover happens, when somebody steals the credentials of one of our clients, then they can kind of abuse the APIs. They can use at least that access that client had. So for example, if we expose authentication APIs, they can be abused by guessing passwords and user credentials. So for example, if somebody found a set of users and password in the dark web, they can test these users against our platform, also known as credential stuffing. This is an inherent sensitivity of the API. It's not necessarily a vulnerability, it's just a sensitivity, and it's really hard to protect against that stuff. Then if somebody has access to the system, they can abuse the system itself. Like for example, if we have a reservation system, let's say we're a hotel, we expose a reservation system. That means that if somebody has access to our system, which can actually be any end user, anybody can maybe open an account. They can, use the APIs to make, certain, reservations or to create, to scrape the data from our system and so on. So that is really, authorized use of the APIs, but maybe it's kind of against what we want the users to use it. Payment abuse. We've seen a lot of different ways of abusing the APIs that are not necessarily just related to vulnerabilities. It's kind of related to the basic operation of the system. So in order to list or to quantify the risk on these abuse cases, we came up with this framework. We call it API abuse case analysis. And that framework enables security teams to list the actual API services starting from the very high level, even if they don't have complete visibility, and they typically don't have complete visibility, and kind of assign a specific business risk and potential loss to these different services. So it starts from the left, from left to right. On the left side, we start with what are these services that you expose. So for example, it can be your reservation system, it can be your authentication endpoints, it can be support and help desk management system, and so on. So these are different services, like in high level, that we expose to the outside. We can start from the very, very high level. Typically, we know that list of services. It doesn't surprise us to create that list. It doesn't mean that we know all the APIs, but at least we know in high level which services are there. Now, for each service, we need to identify what is the client, what is the entity that is using that service. Is it a B2B partner? Is it an end customer? Is it a device that is calling that that API? So for example, the QNAP is a device, a Tesla is a device, right? That is calling a lot of APIs. So it can be a device, it can be a user, it can be a partner. Now, why is it so important to understand the entity? Because then the next step is to understand what could go wrong. I mean, the security threat or security risk. So that entity can become compromised. There are many ways in which it can happen. It depends on the type of entity. What happens if that partner is not implemented correctly? What happens if there is an insider threat, and so on and so forth. So understanding who is the entity really enables us to to come up with these scenarios of threat modeling. What happens if this and that happens? And then finally, when that entity is compromised or misimplemented, what is the potential loss? That kind of goes back to the specific service that we started with. And if it's a payment processing service, there could be monetary loss. If it has user information, there could be PII leakage, and so on and so forth, right? So this is kind of relates, the specific type of data lost for that particular service. So if with that exercise, every security team, can actually create a high-level, map of, what are the services that we expose to the outside, what is the business risk, and what's the likelihood of how can it happen, and what is then the loss when that happens. So that is a pretty generic framework, and recommended to use in every organization. Even if you don't have great visibility on your APIs, at least you can start by identifying the risk and quantifying the risk. That would help with the internal discussions of what needs to come first, where should we focus our our security efforts, and so on. Now let's speak about different types of APIs, and then relate it back to the API security program, or what steps we need to take in order to move ahead and be more mature in the way that we secure APIs. So let's start with the fact that the most commonly known types of APIs are actually the web applications and the mobile applications. We call them B2C APIs. Some of them are proper RESTful APIs driven, and some of them are more like dynamic HTML such as PHP and other types of implementations. We call it collectively APIs. We don't discriminate, against, different types of dynamic content. There are many different ways to implement it. Naturally, more modern environments have some separation between the APIs that just, serve the data and the presentation of the data. But I think where we see a lot of growth today is actually in these B2B APIs. These are the partner APIs or device APIs that that enable headless integration between different different products and different components, and they create much more complexity because every time we need to deliver a new product or through some kind of partnership, we need to create more entry points to our system that typically have a lot of access by design, and we need to trust these partners and their implementations. And of course, we can have agreements with these partners and so on, but we can't completely ensure that their developers are not making mistakes. I mean, the same way that our developers can make mistakes, their developers can make mistakes. So it's really important to be, first to discover all these APIs, but also to monitor how they're being used, because the fact that they're authenticated and authorized doesn't mean that they're used correctly. As we mentioned before, the partner could be compromised, they could be misimplemented. We call these APIs north-south APIs. The reason for this name is that because they come from the outside in. It can be both B2C and B2B. And these are typically the first priority when it comes to API security. Just as a side note, these B2B APIs are growing very, very fast. I mean, while web applications and mobile applications are pretty common and known, typically, I mean, a company that delivers a web application doesn't necessarily create 100 more web applications. They typically focus on one big web application. While B2B APIs, they can create many, many more. And each API may be used differently and so on. So the growth on B2B APIs is really the big concern. The second priority is typically east-west APIs. Those are APIs that are used between components within the same organization. So these are typically secondary priority because they're under our control. We control both ends, both the clients and the servers. And with these West APIs, we still want to be able to see what is exposed and to limit the attack surface as much as we can. But it's typically done after we figured out the north-south situation. And then the third type is outbound APIs. It's those APIs that are on the outside, and our code, our internal code, calls these APIs on the outside. So these outbound APIs are typically, again, second or third priority because we control the client code. And on these outbound APIs, we just want to make sure that sensitive data doesn't leave our premises without kind of accounting for that. But we control the code, so it's less of a risk than these north-south APIs where we have everything to lose, but we don't control the code that calls our APIs. Now, I wanted to maybe focus on the type of problems that we need to solve and how to solve them. So I mentioned that the first problem that people have is that they don't have an inventory of APIs. So we call them shadow APIs, or sometimes there is an inventory, but it's not great, or it's outdated. So discovering APIs is really typically the first step. Then there's all these vulnerabilities. There are different ways to find vulnerabilities, including testing and using some external services and so on. But as I mentioned before, vulnerabilities are not enough to prevent abuse. Vulnerabilities are only one way where, that attackers can use to abuse your system, but abuse can also happen with valid credentials. So in the end of the day, being able to detect and respond to API abuse is really the goal, and that's the highest level of maturity. So we created this 6-step guide of how to get to the right maturity. Typically, the first step is first, to make sure that you have, logs for all these APIs, that which microservices you're exposed to the outside, and you have at least some visibility on the API activity. What you'll find is that these logs are not verbose enough. It's very, very hard to know what's going on just based on these logs. They actually cannot be verbose enough because of privacy issues. You can't just store logs of all the private information that goes through your APIs. So for the same compliance reason that makes you log these APIs, you also can't really log too much. But this is really the first step. There are some organizations that don't even have that figured out. Most organizations that we saw have some logs on API activity, but they don't have the second step, which is API discovery. Discovering your APIs is really most important as an initial step, because without a proper inventory, you don't really have a plan of what to protect and how to protect it. It's actually pretty tricky to do because APIs can change all the time, and the documentation that we get from our developers is partial and it's only point in time. So typically we find that there are many more APIs than the ones that are documented and well known. Once we discover the APIs, we should do we should focus on risk audit and finding vulnerabilities. That of course is a continuous process. And once we're kind of comfortable with the basics, we need to focus on detection and response. And this is really monitoring the production behavior of our application and making sure that it's not being abused by different types of users or authorized users, because some of these authorized users can be attackers or can be implementation errors and so on. In order to do detection and response well, we need to be able to define or to focus what are the business sensitivities, kind of going back to the abuse case analysis, making sure that we monitor that relevant traffic and we know how to detect and respond. These business sensitivities is most important. And of course, response, once we know how to detect, we want to respond automatically. And the last step here, last but not least, is investigation and threat hunting. Without the ability to go back and investigate, it's really, really hard or impossible, I would say, to have a good detection and response framework. So try to move forward one slide. I'll skip a little bit. So for us, for Neosec, our SaaS product basically takes you through all these different steps, from discovering APIs automatically and continuously to finding vulnerabilities in the way that they're implemented, and also finding abuse and through detection and response. All of that while providing the visibility and investigation capability and threat hunting capability on that data. In the end of the day, without being able to do investigation and threat hunting and kind of go back to the data, there's really no way to accurately detect and respond to the detections. So our platform leverages the ingest all that API activity data, continuously create the inventory, finds vulnerabilities, and performs behavioral detection and response, and of course enables detailed threat hunting and kind of the next steps that the security team can take. So I'm happy to answer any questions, and of course happy to talk in more depth after the session for anybody that is interested.
Okay, thank you very much, Giora. Very interesting. I do have a question, guys. If you have any questions, please write them down in the chat. I saw there is a question to Regina, so we will answer the question in the end of the meetup. But Giora, I do have a question. How do you separate between business to customers API and business to business from your security perspective? Is there anything different that you are using, or are you handling it from different risk perspective? What is your approach, attitude toward that?
I think from a technical perspective, there isn't always a technical difference between B2B and B2C. It's more of a logical difference. I think that, in B2C environments, because they're not new. I mean, people were publishing web applications in, the last 20 or more years. So they have some frameworks of understanding, what's going out, how it's implemented, and so on. I think with B2B applications, it's a little bit harder because, first, because the client implementation can be any implementation. It's not really your code. And I think the other hard thing is that you have a lot of different types of these APIs that you develop over time. So I would say that from an API security perspective, people typically start from the B2B use cases because these are new and there's really zero visibility to these use cases today. From a technical characteristics, a lot of B2B APIs are RESTful, which is good news because they're kind of like more standardized in a sense, and that enables also to handle them from a security perspective from a more standard way. But they can be anywhere, and sometimes there are APIs that are used both for B2C purposes as well as B2B. Yeah.
Okay, that's interesting. What are the most common vulnerabilities you see in API? If you can, share with us, because you are seeing all those vulnerabilities. What are the most common, like top 3 or something like that? You can
I
share.
would say the common. I mean, once you know the APIs and so on, the most common vulnerability is different types of BOLA, broken object level authorization, meaning that yes, you're authenticated, but it doesn't necessarily mean that you have access to all the objects in the system, right? All the records and all the different different types of objects, and systems today tend to be complicated, and they have many different types of objects, and there are many places in the code that needs to to check what you have access to and what you don't have access to. So these vulnerabilities are very common, where you can actually access things that you're not supposed to be able to access. But I think what we're seeing in practice is that it's even more basic. I mean, I started my answer by, if you know about the API, I think it starts even earlier. The problem is that security teams don't really have a good inventory of APIs, and they can't really secure what they don't see. So that is an even harder problem for them. I don't know if I would call it a vulnerability, but it's it's that API that was published for a good reason, but it's kind of invisible to the security team, and it's used from now every now and then or by some partners, and all of a sudden maybe somebody found that there are some public keys somewhere that are published, and starting to use that API as an attacker. I mean, there are actually many brands that suffered that type of attack recently, and the problem is that there is really no monitoring on that API at all. So security team didn't even know about it. So that is, I think, even more common.